Okay, let's take a look at another example of solving rational equations. Here we have another problem. Again, we want to find the LCD, that is the least common denominator, and we can take that common denominator and just multiply it by everything in the equation. Okay, so that's one method. Okay. So basically the common denominator, okay, now let's look at this here. Let's look at each denominator, right? We have 5, we have x, and we have 3. Well, the common denominator between 5 and 3 is going to be 15, okay? Because if you take 5, if you take 5 and you take 3, and then you go ahead and do multiples of that number, 5, 10, 15, then you have 3, 6, 9, 12, 15. Clearly see that 15 is going to be your least common multiple or least common denominator, okay? So they are the same thing, all right? And then now, since 15 is my least common multiple or least common denominator, what we want to do is we want to figure out how to make each denominator a 15, and also we have an x here in this fraction, so every one of the denominators needs to have that x as well. Okay, so let's do it like this. Okay, you look at the look at this, right? That denominator, in order to make it a 15, we're going to have to times it by a 5, but it's missing the x variable. Okay, so we're going to have to include that x along with the 5. Remember, what you do to whatever you multiply the denominator by is you need to do the same for the numerator. Okay, the middle fraction has the x variable, but it doesn't have the 15, right? So the only thing that is going to change that to a 15x is you're going to have to times the bottom and top by 15. Okay, and then of course the left fraction, it doesn't matter what fraction you start with. I mean, the bottom line is that the LCD between 5 and 3 is 15, and then we have to include the x. Okay, so the LCD is really 15x. So in order to times the 5, in order to make that a 15, you're going to have to times it by a 3, but again we need to include that x. Okay, because it doesn't have the x in the denominator, and then you're going to do the same with the top. All right, so what is this, how does this mean? How does he break this down? Well, again, if you want to multiply all the numerators and the denominators together to get a simplified version, this would be 9x over 15x plus 15 over 15x equals 10x divided by 15x. So my LCD is going to be 15x for this particular equation, okay? Now, you can look at it two ways, okay? Notice that I didn't multiply the whole equation by 15x. I could have done that, okay? I'll show you that in a minute, but when you do it like this is an alternative way of doing it. You can find the LCD and then now just find the common denominator with each fraction, asking yourself, okay, if my common denominator is 15x, what do I have to multiply each denominator in order to get that 15x? Okay, so that will kind of indicate what you multiply the fraction by. And since the denominators are identical, then all the numerators are going to be this, okay? Since the denominators are identical, then we can just copy whatever is in each numerator as the equation, okay? So, and that's going to be right here. Like, this is literally your equation, okay? It's going to be 9x plus 15 equals 10x, okay? That's the equivalent equation because the denominators are all alike, all right? and you can solve the equation for x. So I'm probably going to subtract 10x, okay? 9x minus 10x is negative x. The plus 15 stays the same. And then I'm going to go ahead and move the 15 over, and then you're going to get negative x equals minus 15. Okay, remember these cancel, that's why I'm doing that. But in order to get a positive x, we are going to divide by a negative 1, and then that's going to give me x equals a positive 15. Okay, and that is going to be your answer for that problem. Okay, now as an alternative, okay, I could have done this. All right, we agreed that 15 was my LCD, right? And we also agreed that the x needs to be included in that because every denominator must have that x, not just the middle fraction, right? So we decided that the LCD is 15x. Well, I could have done this. I could have done this. I could have taken the 15x and I could have multiplied it by the original terms in the equation. So 3/5, right? Plus, again, taking my LCD, 15x, and then I'm multiplying it by 1 over x equals, and then again I'm taking my 15x and I'm multiplying it by 2/3. Okay, and when you do that, you can cancel, okay, you can cancel the denominator with the LCD. So 5 cancels, 5 goes into 15 3 times. So then you have 3 times x times 3, which gives me what? It actually gives me 9x. Okay? Here, this x cancels and this x cancels. So then you have 15 times 1, which is going to be a plus 15. Don't forget to put that plus here. Okay? Bring down your equal sign, and then 3 cancels, because 3 goes into 3 once, 3 goes into 15 5 times, and then you have 5 times 2, which is 10. You notice that I get the same equation as I did over here. 9x plus 15 equals 10x. Okay, and when you solve the equation, you just do the same exact thing. Okay, that should be a 10x, by the way, sorry. All right, and then you just solve the equation, okay, like we did. Okay, and that just gives you minus x plus 15 equals 0. And then we're just gonna subtract the 15. So you get minus x equals minus 15. But remember, we're dividing by a negative 1. And that's gonna yield x equals positive 15. Okay, so we ended up getting the same solution as we did a moment ago. So you have alternative methods here. Some instructors will show you one way, some will show you another. So that's kind of why it's a good idea to maybe learn one method first really well and then explore the other method, because not everyone's going to teach it identical. So we have to make sure we realize that. And that's the solution, x equals 15.